All right, y'all. So number one on the test wants us to graph, and they want me to graph y equals x squared plus 2. So remember, x squared graphs in MATLAB will be the 3-point quadratic tool. So anytime you got an x squared, you're going to use the 3-point quadratic tool. Now, on the x squared graphs, I always use -1, 0, and 1 on those. So what you want to do is put each of these x values into the equation and then solve it for your y. Now remember, these graphs are symmetric. So whatever we got when x is -1 will be the same thing we get when x is a +1. All right, y'all, let me let some people in real quick. Logan. All righty, so first let me put a -1 into that. That would give me y equals -1 squared plus 2. So remember, -1 times -1 is 1. That gives me 1 plus 2, which will give me 3. So when x is -1, y is 3. Then I'll put the 0 in for the x's. So that'll give me 0 squared plus 2. All right, y'all, 0 squared is 0. So that's going to give me 0 plus 2. And adding that will give me a +2. So when x is 0, y is 2. Now I should get some symmetry here when I put this +1 in. So we got 1 squared plus 2. Well, 1 squared is 1 times 1 is 1. So that's going to give me 1 plus 2, which will equal 3. So remember, symmetry on these. So now I would go over here, -1 and up 3. Then I had 0, 2. So 0 up 2. And then I had 1, 3. So right 1 up 3. So once you put in that last point, MATLAB will draw that parabola for you. So I'm going to share my calculator now and do that on the calculator. So you're on the calculator, I would go to y equals, and I would put in my x and square it, and then plus 2. All right, so first I'll graph it just to see what the graph looks like. And y'all, there's the parabola we just drew. Now, if you want to use MATLAB, the calculator to get your points, you would hit second graph to pull up your table. And then, let me let one in real quick. And then notice there's that point I used, -1, I got 3, 0, I got 2, 1, I got +3. So remember, any 3 points when you graph that, okay? So the trick is MATLAB. So remember, in MATLAB, I gotta click to enlarge my graph. Grab that 3-point quadratic tool, and then start plotting your points. So I had -1, 3, so go up 3. I had 0, 2, so go 0, up 2. And then I had 1, 3, so go right 1 and up 3. All right, so there's my U-shaped parabola. So you save that, and then you move on. All right, so going back to my pad now. Number 2 here wants me to graph y equals absolute value of x plus 6. So absolute value in MATLAB uses a 2-point absolute value tool. So we only need 2 points to graph this. But this one is very picky about the first point you plot. The first point we plot has to be what we call the vertex or the V-shaped point here. Now, that point will have a Y value of 0 because it's going to be on the x-axis when we graph this one. So your first point has to be the x value that makes this equal 0 inside the bars. So the only number I can add to 6 to make that a 0 would be a -6. Okay, so the first point has to make this equal 0 in here. So then I would put in my number, -6 plus 6. So work inside the bars first. -6 plus 6 is 0. So then we had the absolute value 0, which is 0. Y'all, if you don't plot this point first, it'll make your graph upside down, okay? Now, after that, I can pick any other point I want. So I usually just get one next to it. So -5, I'll put that in there. But you can use any other point you want, okay? So I got y equals absolute value -5 plus 6. So working inside the bars, -5 plus 6 gives me a 1. And then the absolute value of 1 is 1. So y'all, you would come up here, go to -6, 0, plot your first point. And then I'm going to go to -5, 1, and plot my second point. After you put that second point, MathLab's going to draw your graph for you. So let me show you that one on the calculator, and then we'll go knock it out on the MathLab. All right, so on the calculator, so let me go back to my y equals, and let me clear this. So I got to get absolute on the calculator. To get absolute value on the calculator, you hit the math button, and then you arrow right and highlight that number. Once you got the number highlighted, number 1, ABS, that stands for absolute value. So hit enter on that. And then inside here, you're going to put x plus 6. So x plus 6. And then I'm just going to arrow out. So now I got the absolute value of x plus 6. Let me show you the graph. So y'all, there's the graph. Notice it went left over there to that -6 with that point, like we said. And then if you wanted to get the values from the table, you're going to have to scroll up here until you find where that y value equals 0. So notice my smallest y value right now is 5. So if I arrow up, I get it to where the y value is 0. Okay, you got to have a y value 0 for the first point. And y'all, there's that -6. And then, like I said, these are symmetric also. And as I go to the left side of that in the negatives, you'll start seeing that symmetry. Okay. But just remember, on question number 2, the first point has to be up here where that y value is 0, okay? All right, y'all, so let me go to graph that. So I'm going to click to enlarge my graph. I'm going to use the 2-point absolute value tool. I got to plot -6, 0 first. So let me go over to -6, 0. And then I had a -5, 1. So -5, up 1. Once you plot them 2 points, your graph is set. Now remember, it's got to look like what you got on that calculator, okay? All right, y'all, then you save that. So let me go to question 3. We're going to do it right off of MathLab here. So notice question 3 wants to know whether this is a function. So remember, for a correspondence to be a function, every element in the domain can only correspond to one element in the range. So the x's can only go to one y value, basically. Well, y'all, if you look at this, -5 only goes to a 1. 3 only goes to the 1. 8 only goes to the 1. Although they share the same y value, each one of them x's only corresponds to one range value. So that means this is, yes, a function. So you got to pick. Now remember, it's yes because each element in the domain corresponds to exactly one element in the range. So that would be C for us. All right, y'all, let me write down number 4 here. They're giving us f of x equals 5x squared minus 4x. They want me to find f of 0, f of -1, and f of a 2. So I'm going to go work that on hand real quick. So this one I'm going to put in MATLAB because it's just the answers you're putting in. So for f of 0, we're going to take this expression and put a 0 in for both these x's. So I got 5 times 0 squared minus 4 times 0. So order of operations, exponent goes first. So bring down that 5. 0 times 0 is 0. And then minus my 4 times 0. So all I did was the exponent. Now 5 times 0 is 0. Minus 4 times 0 is 0. And y'all, 0 minus 0 gives me 0. So for f of 0, I would put in a 0. F -1, I'm going to put a -1 in for the x. So I got 5 times -1 squared minus 4 times -1. So once again, I'm going to start with the exponent. So bring this 5 down. -1 times -1 is a +1. And then I'm just bringing everything else down. Now I'll do all my multiplying. 5 times 1 is 5. Now you're subtracting 4 times -1. So these two negatives are going to make that a +4. And then y'all, 5 plus 4 gives us 9. And then finally, f of 2. Now we'll say at this point, you can punch that right in the calculator or punch that one right in the calculator and it'll give you these answers, okay? So f of 2 would be 5 times 2 squared minus 4 times 2. So exponent first. So bring down that 5. 2 squared would be 2 times 2, which is 4. I'm bringing everything else down. Now I'll do all my multiplying. 5 times 4 is 20. Minus 4 times 2, which is 8. And then y'all, 20 minus 8 gives us 12. So for number 4, put in 0, 9, and 12, and then move on to number 5. So I'm going to bring number 5 up here. So 5, they want me to graph f of x equals 4 minus the absolute value of x. Now they're giving us the x values to put in for here. Now you'll notice -2 and 2, -1 and 1, they're going to be symmetric. Because remember, that's absolute value. So that's going to be our V-shaped graph again. So y'all, let's start putting in numbers. So first, f of -2. That'll equal 4 minus absolute value of -2. So bring down that 4 minus. Now, the absolute value of -2 is a +2. So notice, these two negatives do not make a positive when you got that absolute value sitting there, okay? And then 4 minus 2 gives me a 2. So when x is -2, f of x, remember f of x is y really. All right, next we got f of -1. That'll equal 4 minus absolute value of -1. So bring down your 4 minus. Absolute value of -1 is 1. And y'all, 4 minus 1 gives me a 3. All right, next we got a 0. So f of 0 will equal 4 minus absolute value of 0. So bring down the 4 minus absolute value of 0 is 0. So that gives me a +4. All right, then I got f of 1. That'll equal 4 minus absolute value of 1. So bring down the 4 minus absolute value of 1 is 1. And then 4 minus 1 gives us 3. So notice, -1 and 1 both had 3's. So then let's knock out that last one, which was f of 2. That'll equal 4 minus absolute value of 2. So bring down the 4 minus absolute value of 2 is 2. And y'all, 4 minus 2 gives me a 2. So let's see. On this one, in MathLab, you want to plot the middle point first, because that's going to be the V on this. See, the V is either the highest number or the lowest number, depending on what's happening here, okay? So this one will actually be the highest number. So I'm going to go to 0, 4, put my point. And then I'm going to go to 1, 3 for my second point. So go right 1 and up 3. Y'all, once I do that, MathLab's going to come in and draw me a upside down V. So, calculator. So let me go to y equals and clear this out. All right, so this one was 4 minus absolute value x. Remember, to get absolute value, I'm going to hit math, arrow over to number, and hit enter because ABS is highlighted. I'm going to put my x in there, and then I'm just going to arrow out of that. So there's my 4 minus absolute value x. I'm going to hit graph first to show you the graph. So there's our V-shaped graph. Now, go to your second graph and get the table. So you see how these numbers are going up? I would arrow down until I get to the highest number, and then they start going back down again. So see where x is 0 right here. You got your highest point 4. So that's going to be the point of it. And then it starts going down either way. Okay. So on this one, you always want to plot the middle point they give you first. All right, y'all. So let me go to MathLab for this next one. So that was so let me graph 5 real quick. So to graph 5, you got to put in all these answers first. So we had a 2, 3, 4, 3, 2. Now to graph it, grab the V-shape absolute value tool, Like I said, you got to plot the 0, 4 first. So go up to 0, 4. And then I did 1, 3 next. So go right 1 and up 3. Okay, so there's our upside down V. And enter. All right, y'all. So the next one here. Let me increase this just a little bit. So they want to know if this graph is a function. So if it's a function, it has to pass the vertical line test. And remember, the vertical line says that if a graph is a function, a vertical line cannot intersect my graph more than once. Well, if you look at this, if you draw vertical lines up and down, it's going to hit this graph in 2 spots everywhere. So since it's hitting it more than once on this one, you got to put, no, it is not a function. All right, y'all. So now I'm going to go to my paper. So most of these are just figure out the answers and put them in, okay? So let me go to my pad. So these will start around number 7. So I wanted to make sure I showed y'all how to graph on the calculator and on MATLAB for the graphing for sure. So this one, I'm going to find the domain. And they're giving me g of x equals 4 over 7 minus 3x. Now this one they'll give us A, B, C, D answers on. But to find a domain, the only thing we were worried about are fractions. Well, we got a fraction. And remember, the bottom of this fraction cannot equal 0. So to solve it for what values of x would make that equal 0, we set 7 minus 3x equal to 0 and solve that for the variable. Once we got our answer, we're going to kick that out of our domain. So y'all, on this one, I'm going to subtract 7 from both sides. I get a negative 3x equals negative 7. And then we'll divide both sides by negative 3. So that's going to give me a 1x over here. And then this negative divided by negative will make this a positive. And I can't reduce 7/3. So I'm just going to keep that as a 7/3. So the answer that we want for this one would be x such that x is a real number and x cannot equal 7/3. Now, I just want to show you all the answers on that on MathLab. Notice, be careful on this because A has everything right, but they got greater than or equal. We can't use that because that's false. We got to use B on that one that says not equal to the 7/3. Okay. All right, y'all. So let me go. All right. So now we're getting into some function stuff. So number 8, f of x will equal negative 6x plus 6. G of x is going to equal x squared plus 17. All right, on that, they want me to find f of 9 divided by g of 9. F of 9 divided by g of 9. So basically, they want me to put a 9 in for these x's. So y'all, this is f divided by g. So my f is -6 times my x, which is 9, plus 6. I'm dividing that by my g, which will be 9 squared plus 17. Now, if that would have been a -9, remember, I would have had to put it in parentheses when I'm squaring it. Now, on the calculator, if you want this to look exactly like that problem as a fraction, so let me quit this screen here. If you want it to look like a fraction, you hit the green alpha button and the y equals. ND means numerator over denominator, so hit enter on that, and there's your fraction. So put in -6 times 9 plus 6. Arrow down to the bottom, put in your 9 squared plus 17. If you put it in as a fraction, when you hit enter, it'll give you the reduced fraction answer. So y'all, once I hit enter, I get a -24 over 49. Okay, so let me go back and work it by hand. I just wanted to show y'all that that green alpha button and y equals is how you put in those fractions. All right, y'all, so by hand on top, -6 and 9 give me -54 plus my 6 over 9 times 9 is 81 plus 17. All right, so adding the top, I get a -48 over 81 and 17 is 98. And you ought to reduce that, both these numbers divided by 2 because they're both even numbers. So -48 divided by 2 gave you the -24. 98 divided by 2 gave us our 49. But y'all look, when you punch it in on the calculator, it gave us -2449. Pretty quick there, okay? All right, y'all, let's see. Number 9. On number 9, f of x is going to equal -3x plus 4. G of x is going to equal x squared minus 3. They want me to find g minus f of x. So they didn't give me a number on this one. So all we can do when they don't give you a number is try to simplify it as much as you can. So g minus f of x will equal my g minus my f. And on subtraction, you definitely want to put these two functions in parentheses. And then watch out, g is first. G is the x squared minus 3. F is a -3x plus 4. And y'all, the next line will make or break this problem. So first parentheses you can drop and bring out that x squared minus 3. But y'all, the second parentheses, you better distribute that negative like it's a -1. So -1 times -3 makes that a positive 3x. That -1 times that positive 4 will make that a -4. That's the most important step on this whole problem, is getting them two signs right. Now, all you can do is add like terms, which are my numbers. So I'm going to put it in descending order. So my x squared goes first. Then I would bring down my positive 3x. And then that negative 3 and negative 4 add to give us a negative 7. Okay, so on that one, distribute subtraction. All right, y'all, number 10, f of x is going to equal x squared minus 4. G of x is going to equal 14 minus x. On this one, we're going to find f minus g of a 1. So y'all, it's still subtraction, but this time they're giving us the 1 to put in for the x's. So it might be a little easier when they give you a number. So f minus g of x will equal my f minus my g. So f is x squared minus 4. So that's going to be a 1 squared minus 4. G is 14 minus x. So that's going to be 14 minus 1. So I'll just put a 1 in for that x and a 1 in for that x. Now, since they got numbers, I'm going to do it a little different up here, because up here I didn't have numbers. I had to distribute and all that. Here, order of operations, I got to work inside this parentheses and work inside this parentheses before I subtract. So inside my first ones, 1 squared, that's going to give me 1 minus 4. Over here, I'm just going to bring that down as a 14 minus 1. So all I did was my exponent on that one right here. So now 1 minus 4 gives you negative 3 minus 14 minus 1 is 13. And y'all, negative 3 minus 13 will give me a negative 16. But y'all, that can be done on your calculator. Let me show you. So let me clear that out. So I would put in my parentheses 1 squared minus 4, close parentheses, minus my second parentheses, which was 14 minus 1, close parentheses. So it looks just like we had it. Hit enter, and we get our negative 16. So y'all, they're not too bad. You just got to really keep up with signs on this, okay? All right, let me move that back up. All right, so number 11. Number 11 wants me to determine the domain. So we're going to find the domain of f divided by g. So f of x is going to be 10x minus 3. G of x is going to equal 3x minus 21. All right, y'all, so this is division. So f divided by g will equal my f on top, which is 10x minus 3, over my g, which is 3x minus 21. So, y'all, this is just like we did a while ago when we found the domain of a fraction. All we're worried about is the bottom cannot equal 0. So we're going to set 3x minus 21 equal to 0 so we can find out what value of x makes that true. So similar to a while ago, on this one, I'm going to add 21. I get 3x equals 21. Then I'm going to divide both sides by 3. Well, that cancels, giving me my x equals positive 7. Now, let me show you the difference on this one and the one I did a while ago. While ago, they gave me 4 answers to choose out of. On this one, they're going to give you x such that x is a real number and blank. So while ago, they gave you the whole answer and you choose A, B, C, D. This one, they're not giving you what's in the box here. So since we got a 7 that we would put in here to make this undefined, right here we got to put in actually x cannot equal 7. They don't want you to just put the number. You got to put x not equal to 7 on that one, okay? All right, y'all, number 12, f of x equals 6x plus 1. G of x equals, oh, where am I at? X to the third. They want me to find f compose g of a negative 2. So remember, this is like f of g of negative 2. So what we got to do is put that negative 2 into the g equation first. So you got to find what is a g of negative 2. Once we get what g of negative 2 is, we'll put that answer into the f equation. So this is 2 steps to get one answer. So y'all, g of x is x to the third. So I'm going to put a 2 in for that x. And that's going to give me negative 2 to the third power. Well, negative 2 times negative 2 times negative 2 is a negative 8. So now, since that equals negative 8, that negative 8 is going into the f equation. So we're finding f of a negative 8. All right, so f is this one, 6x plus 1. So that's going to give me 6 times negative 8 plus 1. All right, let's see. 6 times negative 8 is a negative 48 plus 1. Adding them together, we get a negative 47. The only answer you're putting in MathLab is that negative 47. All right, y'all, let me go find 13 on MathLab because it's a graph looking one. So go to MathLab and I'm looking for 13 on this. All right, so here's my 13. All right, I'm going to make this larger. So it wants to know if it's 1-to-1. For 1-to-1, I use a horizontal line test going straight across. Now, the horizontal line test says that if a function is 1-to-1, then a horizontal line cannot intersect that graph more than one time. So really similar to the vertical line test for functions. So if it intersects it more than once, it's a no. Well, y'all, on the top or the bottom, if I draw horizontal lines across that, it's going to intersect 2 spots everywhere pretty much. So since it's intersecting it at 2 spots most of the places, this is not 1-to-1. Right? Vertical line and horizontal line, to be true, can only intersect somewhere one time at the most. All right, y'all, so let me see. So 14 deals with that. 14 says, determine if 1 to 1 if it's 1 to 1, find its inverse. So y'all, they're giving me f of x equals 3 over x plus 1. So y'all listen to me. On number 14, put yes, it's 1 to 1. Okay, so let me go to Math Lab. Oh, they changed it. So let me put an 8 on top. This will be 8 over x plus 1. Usually the top number is the only thing they change on these. But y'all, on this question where it says is the function 1 to 1, put yes. Every single one of y'all's will be 1 to 1 on this, okay? All right, so I'm going to change mine to 8 over x plus 1 so we can put our answer in Math Lab. So remember, I had a 3, so the only number they're really changing is the top number on this, okay? So watch how we do this because y'all's is going to be really similar. So we're going to find the inverse. So this is where I replace the f of x with the y. So I get y equals 8 over x plus 1. So do y'all remember what I had to do next when I find the inverses? All right, let me see. No one. Oh, there's my chat. Let me see. Oh, yeah. I got to switch to x and y. Good job. So switch to x and y. So you get x equals 8 over y plus 1. And y'all, now we're solving it for the y. So we can't solve for the y while it's in the bottom of a fraction. So to eliminate the fraction, you multiply both sides by the y plus 1. Because look over here, where I multiplied that fraction by the y plus 1. Those y plus 1s cancel. All that's left is that 8. Now, I'm not going to distribute that because I think that's more work on them when you distribute that x. I'm going to leave it a y plus 1 times x equals 8. Because now, remember, I'm solving for the y. So I'm going to get rid of this x by dividing both sides by the x. And y'all look at that. Those cancel. All that's left is your y plus 1 equals 8 over x. So y'all look, all I did in the long run, x was up here, y plus 1 was here. In the long run, all I did was flip-flop those to where the y plus 1 that was on bottom is now up here, and the x that was on top is now on the bottom. So my last step, subtract 1 from both sides. I'll get y equals 8 over x minus 1. Now, y'all, Math Lab has the F inverse notation already. All we got to do is put in our answer, 8 over x minus 1. All righty, so let me go to put that in Math Lab because that's sort of tricky to put in sometimes. All right, so I'm down here on I would hit the fraction first, put an 8 on top, arrow down, put in your x, and then arrow out from under that fraction and put in minus 1. Okay. All righty, let me see what's next. So, y'all, 15. Let me show y'all what 15's got. Systems of equations. So, y'all, here's my question to y'all. Are y'all solving this on the calculators Or is anybody solving these by hand? So let me look at my chat and see what y'all are saying. Anyone solving these by hand? All right, so I'm assuming everybody is solving these by using the calculator. All righty, so Charlotte says she done both. So yeah. So what you want to see today? Because I can go either way. All right, so y'all want to see both. So let's go with number 15. So let me see what they're giving me here. So for 15, y'all, they're giving me 5x plus 3y equals 44. 3x plus 5y equals 52. All right, so I got them wrote down. So let me solve these by hand first, and then we'll do them on the calculator. So first, you got to figure out which variable to eliminate. And y'all, that's got a 5 and a 3. That's got a 3 and a 5. So it don't really matter which one we eliminate. So I'm just going to eliminate my y's. I usually do my x's, but I'm going to play with my y. So, but notice 3 and 5 don't eliminate yet. So I got to make one positive and one negative. So it looks like I'm going to have to change both these rows, because I can't turn a 3 into a 5, and I can't turn a 5 into a 3. So I got to find the smallest number that 3 and 5 will both go into. And that's going to be 15. So I'm going to make this one a positive 15 by multiplying the first row by 5. And then I'll make this one a negative 15 by multiplying this whole row by negative 3. So remember, the goal is to pick a variable, eliminate it by making one positive and one negative. So I'm changing both my rows. So 5 times 5 is 25x. 5 times 3 gives me a positive 15y. And then y'all, what's that? 5 times 44 is going to give me 220. Now multiplying the negative 3 here. Negative 3 times 3 is negative 9x minus 15y. And then negative 3 times 52 is what? Negative 156. So we made our go. The y's, they're canceled out. So let's see what's left. 25 minus 9 gives me 16x. That's going to equal this side where we got 220 minus 156. That's going to give me 64. So y'all were happy. We got one variable. All we got to do is divide by 16 on both sides. So that cancels, giving me 1x. And then 64 divided by 16 gives me a 4. So I know for sure x is 4. So now I'm just going to come and pick this top equation, put a 4 in for the x, and see what I get for that y. So here's my back substituting. So either one of these equations would work, okay? I just usually pick the 5 times x, which is 4, plus 3y is going to equal 44. So first you would figure out 5 times 4, which is 20. Now to solve that for the y, subtract 20 from both sides. So y'all, let's see, we get 3y, 44 minus 20 gives me 24. And then our final step, divide by 3. So that cancels and I get y is 8. Now, y'all, here's the thing about this answer. In Math Lab, you gotta put this one in parentheses, put the x first, which was 4, and then the y, which was 8, in closed parentheses. It's gotta be an ordered pair, okay? All right, so calculator. So let me clear everything out. So calculator, I'm going to use my matrix. So I hit second, x negative 1 to get my matrix. And we arrow over to edit. Once we get on edit, we hit enter. Now, it needs to know how many rows is our matrix and how many columns. So this one had 2 equations. So it would be 2 rows. So you would do 2 enter. And then it had 3 columns. We had the X column, the Y column, and the answer column. So for these problems, you're either going to have a 2x3 or a 3x4. All right, once I hit my 3 and enter, notice it gave me 6 spots to put my numbers. And all I'm putting is the numbers and not the letters. So I had 5x will be 5, enter. 3y would be 3, enter. And then that equaled 44, enter. My second row, I had 3 for the X, enter. 5 for the Y, enter. 52 for the answer, enter. All right, once you got your matrix set up, you hit second mode to quit. Now I go back into the second X negative 1 for the matrix, and I want to go to the math this time. In the math column, you arrow down, remember, till we find RREF, and we hit enter. Now you go back and get the matrix. So second X negative 1, and highlight. My A is already my 2x3 matrix. It's already highlighted 1. So I'm going to hit enter. And y'all remember, when I hit enter, my answers will be the far right column, and they're going in alphabetical order from the top to the bottom. So notice on the right column, I got a 4 and an 8. So the 4 is my X, and the 8 is my Y. So that one, you got to come in. Remember, you got to use parentheses and do your 4, 8, and then close parentheses. All right, so y'all doing this bad boy by hand also. So what's this number 16? 9x minus y plus a z equals 6. 2x plus 2y minus 3z equals 10. And then x minus 3y plus 2z equals a negative 6. All right, so I got my numbers down, y'all. So all right, so let's knock this out by hand first, and then we'll do it on the calculator. So on these ones, I label these equations 1, 2, and 3 so that y'all can keep up with me. So y'all pick a letter for me to eliminate. So let's see, Angelica, you like doing them by hand. So what are we eliminating, X, Y, or Z? So none of y'all got any preferences on anything to eliminate here? Okay, so I got x's, so I'm going to eliminate those x's. So notice, you got to do this, the elimination, twice because we got to use all three of these equations eventually. So let me start with 9x and this x. I'm going to use the first equation and the third equation. But if I want to eliminate the x, I'm going to take this third equation and multiply by a -9. So what I'm going to do, I'm going to add 1 and 3 together, but I'm going to change equation 3. So let me bring down 1. I didn't change it. 9x minus y plus z equals 6. But I do got to change this row, so let's go. -9 times x is -9x. -9 times -3 gives me a 27y. -9 times 2 gives me a -18z. And then that -9 times -6 gives me a positive 54. All right, y'all, so let's see. Let's add these together. The x's are eliminated. -1 and 27 give me 26y. 1 and -18 give me a -17z. And then my 6 and 54 give me 60. So I'll call that equation 4. Now, let me erase that -9 there. So now, no matter what, we got to eliminate the x using the second row. So I'm going to do the second row, and I'm going to use the third row again. But this time, to eliminate the x, I'm going to multiply that last row by a -2. That way the 2x and the -2x will cancel. So y'all, we're going to add 2 and 3 this time, and we're still going to change row 3. So it's like a 2 elimination process to get rid of that first variable x. So I didn't change 2, so let me bring that down. But I did change row 3 by multiplying by -2. So I got a -2x, positive 6y, -4z, and that's going to equal -2 times -6 is what, a positive 12. But y'all look at that. X's are gone. 2 plus 6 give me 8y. -3 and -4 give me -7z. And then my 10 and 12 give me 22. I'm going to call that equation 5. So now, equation 4 and 5 have y's and z's, both of them, since we eliminated those x's. So let's put them two together. So there's 4, and 5 was 8y minus 7z equals 22. So there's row 4 and 5. Oh, Lord, y'all. Woo, I got 26 and 8. 8 don't go into 26. And then I got a 17 and a 7. Okay, so I'm probably going to eliminate the z's on this one. Whoops, eliminate the z. But you can do the y's or the z's. So both of these rows are definitely going to change. Now, 7 and 17, I'm just going to multiply them together to get the smallest number they get. So I'm going to multiply this row by, say, 7. Actually, I'm going to multiply, that row by 7, which means this row, I'm going to multiply by a 17. Because remember, one's got to be negative and one's got to end up being positive. So when you get ugly numbers like this, multiply the top row by the bottom number and the bottom row by the top number. Just make sure you get one of them positive and one of them to be negative. So, woo, MathLab didn't like me on this one. So, y'all, 7 times 26 gives me 182y. So, remember, I'm changing my top row. 7 times negative 17 gives me negative 119z. 7 times 60 gives me 420. Now, changing this row, negative 17 times 8 gives me a negative 136y. Negative 17 times negative 7 gives me a positive 119z. That's what I needed for sure. And then negative 17 times 22 gives me a negative 374. So I got big numbers, but once I add these together, the numbers are going to shrink pretty good. But the first thing, the z's cancel. Now, y'all, if I wanted to get rid of the y's, I would have done this one by 8 and this one by negative 26. Okay, so we pick z's on that. So let's see what 182 minus 136 gives us. So that's going to give us 46y. And then how about the 420 minus 374? Ooh, that's giving us 46. So I'm down to one variable. So 46y divided by 46 will equal 46 divided by 46. Well, all these 46s are going to cancel, giving me a 1y equal to 1. So I finally got one of my variables. So now I'm going to plug it into one of these two equations and solve for the z. And my 5 looks easier than this equation 4. So I'm going to back substitute into my equation 5, 8 times y, which is 1, minus 7z equals 22. All right, so 8 minus 7z equals 22. Subtract 8 from both sides. Negative 7z equals 14. And then y'all divide both sides by negative 7. So z is going to equal a negative 2. So I know what the y is. I know what the z is. So I'm just going to plug into one of these three equations and solve it for the x. So y'all, this last one's got the smallest numbers. So I'm going to back substitute into the x minus 3y plus z, 2z equals negative 6. I don't know the x. I know minus 3, y was 1, plus 2 times z, which is negative 2. All that's going to equal negative 6. All right, so here we go. Multiply and multiply. So x minus 3, 2 times negative 2 is negative 4. Add these like terms. X minus 7 equals negative 6. And y'all finally add 7 to both sides. And x equals positive 1. Now, here's the difference. On this one, MathLab gives you the parentheses, and they give you the 3 boxes. So all you got to do is put in your x, your y, and your z. They already given us the parentheses on that one, okay? So y'all look, this problem takes a whole page almost. When you get this answer on this kind of problem, you're really happy because that's a lot of work, okay? Now to check yourselves, let's go to that calculator. So let me clear this screen off and clear my history. Alrighty, so second, x negative 1 to get the matrix, go to edit and enter. So remember, this one had 3 equations, so that would be 3 rows by 4 columns. I got the X column, Y column, Z column, and my answer column. All right, y'all, all we need is numbers on this. So I had 9x, so that'd be 9 enter. Minus a Y would be -1 enter. Plus a Z would be 1 enter. And that first row equaled 6 enter. Second row, 2 X's, 2 enter. 2y, 2 enter, minus 3z, -3 enter. In the second row equaled 10, and enter. Third row, I had 1x, so 1 enter, minus 3 for the y, 2, whoops, let me go back. Minus 3 for the y, enter, and then 2 for the z, enter, and then that row equaled -6, and enter. So y'all got all my numbers in. Quit the screen by hitting second mode. And remember, the rest of this is just doing the math stuff. So second, x -1, highlight math, go down to RREF, enter, go back and get your matrix, second, x -1, enter. And remember, the right column will be our answers in alphabetical order. And there's our 1, 1, -2. All right, so let me find that math lab. So see how this one's got the X's and the parentheses? So you're just going to go in and put your numbers. And then that was what, a -2. All right, y'all, then you go to next. Now, y'all, this one's not as bad as the one I just did. But let me show you what I'm going to do to this before I even put the numbers down. I'm going to come over here, and I know I got eggs. So eggs will be my X's. They're going to be my first column. Then I had the cupcakes next. So cupcakes will be my Y's. And then my pizza will be my Z's. And then I have my milligrams of cholesterol will be my answers. So I just like to get my columns organized for these word problems like this one. So now let's go read what we got. So I got 1 egg, so that'll be X, plus 1 cupcake will be plus a Y, plus 1 pizza will be plus a Z, and that's going to equal 303. So my first equation, X plus Y plus Z equals 303. Next row says if a child eats 3 cupcakes, so that'll be 3Y. In 4 slices of pizza, that'll be 4Z. That's going to equal 89 milligrams. So my second equation, 3Y plus 4Z equals 89. Now my last sentence has 3 eggs, so that'll be 3X plus 1 cupcake will be plus 1Y. And then that's going to equal 847. So my last equation, 3x plus y equals 847. Now, y'all, I'm going to tell y'all the truth. Let me label my equations. Every time I've done this equation, the eggs usually ended up with 280 or so. Pizza usually ended up like 8, 9, 10 or so. And then the cupcakes were like in the 16, 17, 18, 19 range. Every single time I've done that, okay? Eggs have been the highest. Now, I would do this one different than I did a while ago. On this one, since the y is in every one of these, I probably wouldn't eliminate the y. I would probably eliminate the x's or the z. Because the other equations that are missing, you'll see we can use them as a second equation, and we don't have to actually do the elimination stuff twice if we pick these variables. So y'all on this one, let's see, I'm going to eliminate, how about the x's again? So if I'm going to eliminate the x, this one has a 3x, and this one has a 1x. So I'm going to multiply the first row by -3. So what I'm going to do, I'm going to add 1 and 3, and I'm going to change row 1. So y'all, let's multiply by that -3. You're going to get a -3x minus 3y minus 3z equals a -909. Now, I didn't change row 3, so that was 3x plus a y equals 847. So y'all look at that. The x's cancel. -3 and 1 give you -2y minus 3z. So y'all, let me see. I got a -909 plus 847. That's going to give me a -62. So technically, that would be equation 4. Well, y'all, look at this middle equation. It's got y's and z's just like this equation. So equation 5 is automatically going to be the second equation. 3y plus 4z equals 89. So if you eliminate the z's or the x's, either this equation or that one becomes the second equation. So let's put these together. -2y minus 3z equals -62. This one has a 3y plus 4z equals 89. All right, so it looks like no matter what we pick, we'll have to change both rows because I can't turn a 2 into a 3, and I can't turn a 3 into a 4. So I'm going to add both these rows, and I'm going to eliminate. I'm going to have smaller numbers. I'm going to eliminate the y this time. Now, that one's already negative and positive, so I'm going to multiply this row by 3 and this row by 2. So here we go. I get -6y minus 9z equals a -186. This one will give me a positive 6y plus 8z equals, so let's see, 89 times 2 gives me 178. But y'all look at that. The y's cancel. -9 and 8 gives me a -z. So let's see, -186. And 178 give me what? A -8. All right, remember, divide both sides by -1 because we want z to be positive. So Z equals a positive 8. But remember, you're looking at milligrams in these things. The milligrams got to be positive. In fact, all three of these answers got to be positive because we can't have negative milligrams of cholesterol in this stuff, okay? All right, I know Z is 8, so I'm going to pick one of these two equations. I like this one better because this one's got too many negatives. So I'm going to put that 8 in for that Z. So I got 3y plus 4 times 8 equals 89. So that'll be 3y plus 32 equals 89. We're going to subtract 32 from both sides. 3y, that's what 57, y'all, and then divide both sides by 3. So that cancels, and y equals, let's see, 57 divided by 3 should be 19. And there you go. So now I know y and I know z. All I got to do is find my x. So I might use this bottom one because I know y. So I'm just going to back substitute and figure out what that 3x is going to give me. So back substitute for your third. So 3x plus y, which is 19, is going to equal 847. All right, so I'm going to subtract my 19. So y'all, let's see. 847 minus, what did we say, 19 will give us 828. Divide both sides by 3. Whoops, I said 828, didn't I? So 828, not 826. So 828 divided by 3, let's see what that gives us. 276. So remember, I said the eggs would be 200 and something. The cupcakes are usually in the teens, and the pizza is usually in numbers less than 10. All right, so watch how you got to put these answers in. These ones you actually got to fill in the blanks. So the eggs was my X, so 276. Cupcakes was my Y, so that'd be 19. And then the pizza was my Z, which was 8. So y'all put all them in, and then, oh, I got to do that one on the calculator. So let me go to calculator because this one, you got to remember a few things on it. So second matrix, second x negative 1, go to edit and hit enter. So it's still a 3x4, so enter, enter. See on the first row, x plus y plus z equals 303, so that'd be 1, enter, 1, enter, 1, enter, and 303. But the second row was 3y plus 4z equals 89. There's not an x here for the eggs, so you got to put a 0 for the missing x. And then you had 3y, so 3 enter, 4 pizza, 4 enter, and then 89. So y'all, everybody on the second row, that first number will be a 0 on your second row. Then on the last row, I had 3 eggs, 1 cupcake. I had 0 Z's, so no pizza, so that was a 0. Enter, and then my 847, enter. So your second row will have a 0 for the X. Your third equation will have a 0 for the Z. All right, y'all, quit that screen by hitting second mode. Let's go get the math. Whoops. Second, x negative 1. Arrow over to math. And then go down and get RREF. Enter. Go get our matrix. Second, x negative 1. Enter. And then enter. And hopefully we get 276, 19, and 8. So once again, remember, they're in alphabetical order. Oh, y'all, hang on. Let me get back to my math lab. I hit the wrong button. All right, so we done entered them while go. So we hit next. So now you got the 3 shading problems. So this is 18, 5x minus 2y is less than or equal to negative 6. All right, so I got it wrote down. So let me go to my paper. Now, y'all, I will say this. Whether you do this one on the calculator or by hand, you got to be able to solve this one for the y. That's the whole issue with this problem, is being able to get that y equal or whatever to whatever. So you got to get the y solved for. So first, move the 5x by subtracting 5x. So those cancel, and you got negative 2y less than or equal. So these are not like terms. So I want to put my x's first. So I'm going to do my negative 5x minus 6. Now here's the trickiest part on this problem, is that we got to divide all 3 of these by that negative 2. And since I'm dividing by a negative, less than or greater than now becomes a greater than or equals. So just remember, divide by negatives, reverse the inequality. The golden rule about inequalities is dividing by that negative. So negative 2 divided by negative 2 makes that 1y greater than or equal. So negative 5 divided by negative 2, the negatives cancel, making that a 5/2 x. And then when you subtract 6 divided by negative 2, those 2 negatives make that a positive 3. So on this one, I would definitely pick a 0, because 0 times 5/2 is 0. 0 plus 3 gives me a 3. Second number would match the bottom of that fraction. So since that's a 2, my second number would be a 2. And I'll show you why. So if I put a 2 in for that x, well, you always want to match the denominators because that stuff cancels. And all that's left is 5 plus 3, which gives me a 8. So when x is 2, y is 8. So I got my 2 points. So I'm going to go to Math Lab first, and then I'll show you the calculator. So click to enlarge tool. So remember, I had y greater than or equal to 5/2 x plus 3. So we got to choose the line tool. And then you got to figure out, is it going to be a solid line or dotted? So y'all remember, I had some equals in that one, so it's going to be the solid line. And they've already got the solid line highlighted. So I'm going to do my point 0, 3 first. And then my next point was 2, 8. So 2 and up 8. So I got a solid line, and it's greater than. So greater than, you would grab that paint can and highlight above that line. Okay, so once you do that, hit save. Now, remember how that looks, because we're about to do that on the calculator. So let me clear everything. So the calculator, go to y equals, and I put in my 5/2 x. So let me clear that. Remember, I want it to look like a fraction. I'm going to hit alpha y equals and enter. I'm going to put my 5 on top, come down and put my 2, arrow right, put your x, and then we had plus 3. All right, so let me show you the table real quick before I shade. If you do second graph and look at the table, do you see if it's a number that's a multiple of 2, you got easy numbers to plot. But if you get an odd number on this one, you got to graph fractions. So that's why I picked that 0 and that 2, so that I could get a 3 to y value and an 8y value. So, all righty. So now, let me go back to y equals, because remember, I'm going to shade it. So to shade it, I arrow all the way left of the y1, and I hit enter until I get the triangle that's bigger on the top. So that's my triangle bigger on the top. Hit graph. And y'all, that graph looks just like the graph we shaded. All right, y'all. So let me put my chat up because I'm going to ask y'all about this one. This graph says x is less than 4. When y'all draw this graph, since it's only got an x variable, is this thing going to be a vertical line or is it going to be a horizontal line? What do y'all think? Oh, I'm done stumped y'all again. All righty, y'all. So let's go to my pad. Oh, y'all must be delayed a little bit, but Charlotte, you're perfect. That is a vertical line. X's are always vertical line. So since it's the vertical line, let me show you what I do on MathLab. Remember, y'all, vertical lines go up and down. And this is the only one you can't graph on the calculator because it's with X's and not Y. So on this one, I hit the line tool. Now remember, this is less than. It does not have the equals. So you got to come down there and click the dash line, okay? This has to be a dash line. So what I do, since it's x less than 4, I go to 4 on the x-axis, and I put my first point. Now, vertical lines go up and down, so you can go anywhere up here, anywhere down here, as long as you got a straight line. So, y'all, I can click it way up here. There's my straight line. It's dashed. Now, less than shades to the left, greater than would shade to the right. And y'all, if you look at that little inequality, it's pointing to the left. So that means I'm going to grab my paint can and highlight the left side. That little inequality, when you're dealing with x's, points to the side you got to shade. Okay, so that is pointing left. All right, save that. And then we go to our next one. All right, so this one we can do on the calculator. Now, what you would do by hand is pick two numbers for the first equation, two numbers for the second equation, graph them and see where they overlap. So let's play with that on this calculator. So I'm going to go to y equals and clear that. And I'm going to clear my history over here. Oh, y'all, let me get I didn't grab my equations. So I got y is greater than or equal to x plus 2. Y is less than or equal to 2 minus x. All right, so my first equation was x plus 2. So x plus 2. Now, it was greater than, so I'm going to go all the way left and get the triangle and hit enter until I get the triangle that's larger above. All right, so I got that one. Now I'm going to go down here to y2, put in my second equation, which is 2 minus x. Now that one was less than, so I'm going to go all the way left and hit enter till I get the triangle that's larger on the bottom. All right, y'all, got my two triangles set up. So now if you wanted to graph them, well, you don't have to graph these by hand, but if you wanted to, you could hit second graph and go to your table. So this one, I'm going to graph it, and I'm looking for the double shaded area. So y'all notice this graph, because y'all about to tell me A, B, or C, or D. So notice what I got. Now let's go to Math Lab. So knowing what I just graphed, A, B, C, or D, what's my answer? So y'all picture again. So notice where it's double shaded at. Okay. So B, that looks good to me, B. I think 90% of the time, the ones I've done have been shaded on that left side like that, but I can't be 100% sure, okay? So y'all, that is our test 2 review. I mean, test 1 review. So here's the thing. Do the review, because the review counts as the grade. So you got to do the review. And I would probably do that review until I really got a good score on this. Okay? Because you can do the review as many times as you want. Now the test you can only do one time. So that's why you want to do the review till you get a good score, because you can do it as many times as you want. The test is just like it, but you only get one shot. So y'all, test 1 is now open. And test 1 will be due by Sunday night, okay? So let's see, that's what, the 24th, I think. Whatever Sunday is. So test 1 will be due that night. So that gives you time to play with the review and then knock out your test. Now, we will start new material Thursday morning, but it's not real heavy, so it won't weigh you down before you knock out my test, okay? So especially 7-1 is really easy. And then 7-2, not too bad either. So I'm going to stop my recording